Think you know everything about Earth? Think again today. We're uncovering 10 fascinating facts about our planet that will blow your mind. Let's dive right in. So you think Earth is a perfect sphere? Think again. Our planet is constantly spinning, creating centrifugal force. This force is strongest at the equator, causing it to bulge outwards. This shape is called an oblate spheroid. It means Earth's diameter at the equator is slightly larger than the diameter between the poles. This bulge affects everything from ocean currents to Earth's wobble on its axis. Earth is round, but not just any round. It's an oblate spheroid shaped by its own spin. Let's talk about Earth's age, 4.54 billion years. This number is almost incomprehensible, stretching far beyond the span of human history. To put it in perspective, if Earth's history were compressed into a single day, humans would only appear in the last few seconds before midnight. How do we know this? Meteorites act like cosmic clocks. These ancient space rocks have been traveling through the cosmos for billions of years, carrying within them the secrets of the early solar system. When they fall to Earth, they bring with them a record of time that scientists can decode. Scientists use radiometric dating to measure the decay of radioactive isotopes in rocks and meteorites. This process involves analyzing the proportions of different isotopes within a sample. Over time, radioactive isotopes decay into stable ones at a predictable rate, acting like a natural clock that allows us to date ancient materials. By comparing these ratios, we determine Earth's age with remarkable accuracy. This method has been refined over decades, allowing us to pinpoint the age of Earth and other celestial bodies with great precision. It's a testament to human ingenuity and our desire to understand the universe. Imagine a world of molten rock and constant bombardment from space. In its early years, Earth was a hostile environment with volcanic eruptions and meteor impacts shaping its surface. This chaotic period was crucial in forming the planet we know today. Over billions of years, Earth cooled, changed, and evolved. The molten surface solidified to form a crust, and the atmosphere began to develop. These changes set the stage for the emergence of life and the diverse ecosystems we see today. Volcanoes erupted, oceans formed, and life emerged. The first simple organisms appeared in the oceans, gradually evolving into more complex forms. This process of evolution has continued for billions of years, leading to the incredible diversity of life on Earth. Every rock and fossil tells a story in Earth's epic saga. Fossils provide a window into the past, revealing the forms of ancient life and the environments they lived in. Geological layers in rock formations act as pages in a history book, recording the changes that have occurred over time. It's a reminder that we are just a blip in the grand scheme of things. The vastness of Earth's history puts our own existence into perspective, highlighting the fleeting nature of human life compared to the enduring story of our planet. So next time you feel stressed, remember, Earth has been around for over 4 billion years. Our worries and concerns are just tiny moments in the grand timeline of our planet. Take a moment to appreciate the beauty and resilience of Earth and find comfort in the continuity of its history. We call our home planet Earth, but maybe we should call it ocean. Over 70% of Earth's surface is covered in water. We've explored more of outer space than our own oceans. These oceans regulate our climate, absorb carbon dioxide, and are home to incredible life. From microscopic plankton to giant blue whales, the oceans are teeming with life. It's our responsibility to protect these precious ecosystems. Earth's atmosphere is like a superhero cape, shielding us from space dangers. It blocks harmful radiation from the sun, like a planetary sunscreen. The atmosphere also traps heat, keeping our planet at a comfortable temperature. This greenhouse effect is essential for life, but can lead to global warming if excessive. The atmosphere provides the oxygen we breathe and protects us from space debris. Most meteoroids burn up in the atmosphere, creating shooting stars. It's a reminder of the delicate balance that makes life on Earth possible. Our atmosphere is essential for life as we know it. The Moon is slowly drifting away from us at 3.8 centimeters per year. This might not seem like much, but over long periods it adds up significantly. The Moon's gradual retreat is a fascinating phenomenon that has been occurring since its formation. Scientists have been able to measure this drift with incredible precision using laser reflectors left on the lunar surface by the Apollo missions. This lunar retreat is caused by the gravitational interaction between Earth and the Moon. The gravitational forces between these two celestial bodies create a complex dance that affects both of them. The Moon's gravity pulls on Earth's oceans, creating tides. The Moon's gravity creates tides on Earth, leading to a slight bulge. This bulge is not static, it moves around the Earth as the planet rotates. The interaction between the Earth's rotation and the tidal bulge is what causes the Moon to drift away. This bulge exerts a gravitational pull on the Moon, causing it to move into a higher orbit. Essentially, the energy from Earth's rotation is transferred to the Moon, pushing it farther away. This process is known as tidal acceleration. Over millions of years, this adds up. The cumulative effect of this tiny annual drift has significantly altered the distance between the Earth and the Moon since their formation. Billions of years ago, the Moon was much closer to Earth. In fact, when the Moon first formed, it was only about 22,500 kilometers away, compared to the current average distance of 384,400 kilometers. This slow drift also impacts Earth's rotation, making our days slightly longer over time. As the Moon moves away, the Earth's rotation slows down due to the conservation of angular momentum. This means that our days are gradually getting longer, albeit by only a few milliseconds per century. It would take billions of years for the Moon to completely escape Earth's gravitational pull. However, long before that happens, the Sun will have evolved into a red giant, potentially engulfing both Earth and the Moon. So while the Moon's drift is a slow and steady process, it is part of the dynamic and ever-changing nature of our solar system. Earth's core is as hot as the Sun's surface, reaching up to 5,500 degrees Celsius. This temperature is almost unimaginable, considering that the surface of the Sun is blistering hot. Yet deep beneath our feet, the core of our planet matches this intense heat. The core is a solid ball of iron and nickel surrounded by a molten outer core that generates immense heat and energy. This intense heat comes from leftover heat from Earth's formation and radioactive decay. When Earth was formed about 4.5 billion years ago, it was a molten mass. Over time it cooled and solidified, but the core retained much of this primordial heat. Additionally, the decay of radioactive elements within the Earth continuously generates heat, contributing to the core's high temperatures. Elements like uranium, thorium, and potassium release heat as they decay. These elements are found in the Earth's crust and mantle, and their radioactive decay is a slow process that releases heat over millions of years. This heat gradually makes its way to the core, adding to the already intense temperatures found there. This heat drives plate tectonics, creating earthquakes, volcanoes, and mountain ranges. The movement of tectonic plates is a direct result of the heat from the core causing convection currents in the mantle. These currents push and pull the plates, leading to the formation of mountains, the eruption of volcanoes, and the occurrence of earthquakes. It also generates Earth's magnetic field, protecting us from harmful solar radiation. The movement of molten iron in the outer core creates electric currents, which in turn generate the magnetic field. This magnetic field extends far into space and shields our planet from the solar wind, a stream of charged particles emitted by the Sun. Earth's core is a reminder of the incredible heat and energy within our planet. The core's heat is responsible for many geological processes that shape our world. From the creation of new land through volcanic activity to the recycling of the Earth's crust via subduction zones, the core's influence is profound. Even in the coldest depths of space, our planet is a source of incredible heat. The contrast between the frigid vacuum of space and the fiery core of Earth is stark. This heat is not only a testament to the dynamic nature of our planet, but also a crucial factor in maintaining life as we know it. Earth's core powers our planet from the inside out. It is the engine that drives many of the processes that make Earth a living, breathing planet. From the heat that fuels volcanic eruptions to the magnetic field that protects us, the core is central to our planet's vitality and resilience. Earth is the densest planet in our solar system. Our planet packs more mass into its volume than any gas giant. Earth's impressive density is due to its composition of heavy elements like iron and nickel. This density gives Earth a strong gravitational pull, keeping our atmosphere from escaping. It also shapes Earth's internal structure and drives geological processes. Earth is a true heavyweight in the solar system. Ever wonder where the Moon came from? The Theia impact theory explains it. Early in Earth's history, a Mars-sized planet named Theia collided with our young planet. The impact released more energy than 1 billion atomic bombs. Debris from the collision formed a ring around Earth, eventually coalescing into the Moon. This theory explains the Moon's composition and orbit. Theia's legacy lives on in the form of our celestial companion, the Moon. From the Amazon to Antarctica, Earth is teeming with an astonishing array of life. Millions of species thrive in unique environments, a testament to evolution. Biodiversity is essential for the health of our planet. Each species plays a role in the delicate balance of nature, yet this incredible tapestry of life is under threat. It's our responsibility to protect this precious heritage. Earth's magnetic field is an invisible shield against charged particles from the sun. Without it, solar wind would strip away our atmosphere, leaving Earth barren. The magnetic field is generated by the movement of molten iron in Earth's core. It acts like a giant bar magnet, creating a protective bubble around our planet. When solar wind collides with the magnetic field, it gets deflected. Some particles create auroras, those spectacular displays of light. Earth's magnetic field is a silent guardian protecting us from space. From a planet colliding past to a moon on the move, we've uncovered some mind-blowing truths about Earth. The more we learn, the more we realize how much more there is to discover. If you found this video interesting, don't forget to like, comment, and subscribe for more amazing content about our planet. Stay curious, my friends.